All right. Time to dive into something I know a lot of you have been requesting how to absolutely crush it in your coding interviews.
Always a popular one.
Right. So, to help us out today, we've got this awesome article, 5 Proven Techniques to Approach Any Coding Interview Problem.
Sounds like a good starting point.
It really is. And what we're going to do today is go beyond just like memorizing algorithms. We're talking about really building up that problem-solving mindset.
It's like having a mental toolkit ready for anything.
Totally. And you know what? The first tool in our kit today is, well, it's called brute force. And I gotta admit, it sounds a little primitive at first.
It does, doesn't it?
It's like if you lose your keys and instead of trying to remember where you last saw them, you just...
Try every single key on the ring until one works.
Exactly. But here's the thing. Sometimes in coding, that kind of brute force approach can actually be helpful.
It's all about understanding the problem first. Sometimes taking that step-by-step, try everything route can actually illuminate the path to a more elegant solution.
Yeah. Even if you don't end up using brute force in the interview, being able to explain it shows the interviewers you're thinking through all the angles. A good example of this is finding what's called the maximum Subari sum. So picture this, you've got a bunch of numbers, right?
Okay, got my numbers.
You need to find the set of numbers right next to each other that add up to the biggest possible number. Brute force would be checking every single group, adding them all up, and seeing which one comes out on top.
It's about being methodical, for sure. Sometimes that's what you need. But let's say you want to get a little fancier, a little more, I don't know, Wall Street with your approach.
Now we're talking greedy algorithms. And honestly, the name's a little misleading.
Wow. It does make you think of, well, certain financial strategies.
Right. So what's the deal with greedy algorithms? What makes them so bat greedy?
It's all about optimization, really. Let's say you've got a day filled with meetings and appointments all overlapping. A greedy algorithm would be like that super organized friend who swoops in and says, okay, we're going to tackle this meeting first because it ends the soonest, then we're going.
Maximize your time.
Exactly. You're making the best possible choice at each individual step and hoping it leads to the best outcome overall. Of course, this only really works if the problem has what we call the local choice property, which basically means that making the best choice at each step actually does lead you to the best overall solution.
Okay, so kind of like choosing the tastiest appetizer, then the most appealing main course, and finally, the most delicious dessert.
I like the way you think.
So if we're looking at a coding problem, how do we know if it has this local choice property? What should we be looking for?
While there isn't a magic phrase, there are some hints. Keep an eye out for clues like maximize the output or find the shortest path. Those often indicate that a greedy algorithm might be a good fit.
But just like that friend who's a scheduling whiz, greedy algorithms aren't always right. Sometimes that focus on the immediate can backfire.
You're absolutely right. It's not a guaranteed win every time.
It's like thinking that buy one, get one free sale is such a steal, but then you get home and realize...
Only needing one thing, and now your pantry's overflowing with something you're never going to use.
Exactly. So greedy algorithms, they're great to have in your back pocket, but maybe not always the go-to solution. But hey, speaking of tools in our problem-solving toolkit, I've heard a lot of buzz about this next one, dynamic programming.
Now that one sounds kind of intimidating.
Yeah, it does sound a little intense, right? But it's basically like having a photographic memory for code, which, let's be honest, would be pretty handy in a coding interview.
Oh, in a coding interview, that would be amazing. Sign me up for that.
Right. So walk me through it. How does dynamic programming even work? What does it even mean?
Okay, so think about it like this. Imagine you're building something massive out of Legos.
Okay, I'm picturing it.
You wouldn't want to start from square one every single time you needed to add, like, a window or a door, right?
Oh, definitely not. Especially not with a clock ticking. And isn't that kind of what a coding interview feels like? A race against the clock?
Oh, totally. That's a great comparison. And that's where dynamic programming comes in. It's all about efficiency. So you break down a complex problem into those smaller, manageable Lego bricks, or, in coding terms, subproblems.
And those sub-problems, we've got to solve them first, right?
Right. And here's the key is that you store those solutions in your code's memory.
Okay, so it's like the next time you encounter that same subproblem, you don't have to reinvent the wheel.
Precisely. You've got the blueprint ready to go. It's all about saving time and energy. The classic example of this, and one the article mentions too, is the Fibonacci sequence.
Okay, yeah, I've definitely heard of that one. It's that series of numbers where each number is the sum of the two before it, right?
Exactly. So you've got 0, 1, 1, 2, 3, 5, 8, and so on. And if you're trying to calculate those later, bigger numbers, it can get really complicated really fast.
Yeah.
But with dynamic programming, you're storing the results of those earlier calculations, so you don't have to keep recalculating them over and over.
It's like having a cheat sheet.
Exactly. But one that you built yourself based on your previous work. So let's do a quick recap of what we've covered so far. We've got brute force, which can be helpful for understanding the problem, but maybe not the most elegant. Then we've got our greedy algorithms, which are all about optimizing each step as long as that local choice property is in play. And now we've got dynamic programming, which is basically like giving your code a photographic memory. What else is in our coding interview toolkit?
Okay, so this next one, divide and conquer, I've got to say, just the name of this technique already has me feeling more confident.
I love it. A little confidence boost never hurts, right?
Right, so what's the strategy here? How are we dividing and conquering these coding problems?
Imagine you're facing, I don't know, a totally overwhelming task, like sorting a gigantic, completely jumbled list.
Oh, my nightmare.
Right. So divide and conquer would be like saying, okay, instead of tackling this whole monster at once, let's break it down. We're going to split this huge list into smaller, more manageable chunks.
Okay, so we divide those problems up and then...
Then, and this is key, you solve those smaller sorting problems first. Once you've conquered those individually, you merge those solutions back together and boom.
You've got the whole list sorted.
Exactly. It's like organizing a library.
Yeah.
Instead of trying to shelve every single book at once, you organize by genre, then by author, and then finally alphabetically within each author.
So satisfying. Okay, and speaking of satisfying, this last technique, the two-pointer technique, it sounds pretty elegant.
Oh, this one's a classic.
It's
all about efficiency, and interviewers love efficiency.
Okay, so how do we use this two-pointer thing?
Okay, so picture this. You're looking for a specific word in the dictionary, right?
Okay, I'm with you.
Now, you can flip through every single page hoping to stumble upon it.
Yeah, that doesn't sound very efficient.
Exactly. Or you could use your two index fingers, your two pointers, to strategically narrow down your search. You start at the beginning and the end of the dictionary and kind of work your way in.
Oh, I see. So it's like if I'm looking for the word, say, algorithm, I don't have to start at aardvark. I can skip ahead using my pointers to zero in on the right section of the dictionary.
Exactly. Now, in coding, the two-pointer technique is especially handy when you're working with something called sorted arrays. Think of it like our alphabetized dictionary. So let's say you need to find two numbers in that array that add up to a specific target number. Instead of checking every single pair, which would take forever, you use two pointers, one at the beginning of the array and one at the end.
So I'm only checking two numbers at a time.
Right. You check the sum of those two numbers. If the sum's too high, you move the right pointer one spot to the left. Too low, move the left pointer to the right. Keep going like that. And you're strategically narrowing down the possibilities.
Until, boom, those pointers meet. They're like high-fiving in the middle of the dictionary. I love it. But wait, what if those pointers meet and I still haven't found my answer?
That's a great question. That means that the specific pair of numbers you're looking for, they're just not in that array. It's like realizing the word you're looking for isn't in the dictionary at all.
Okay, good to know. But when it works, it's gotta feel pretty slick.
It really is. This technique is all about working smarter, not harder. And that's something interviewers definitely notice. It shows you're thinking about efficiency, which is key in the world of coding. It's like finding a shortcut in a maze. You get to the end faster, and everyone's impressed. All right, so we've covered a lot. We've talked about brute force, greedy algorithms, dynamic programming, divide and conquer, even the two-pointer technique. That's a whole arsenal of problem-solving tools right there.
It's impressive, but I'm guessing it's not as simple as just like picking one at random and hoping for the best.
You got it. It's not a one-size-fits-all situation. Each of these techniques has its own strengths, its weaknesses, and knowing when to use which one, well, that's where the real skill comes in.
So how do we develop that instinct? How do we know which approach to use when?
Practice, practice, practice. The more you work with these techniques, the more you start to see those patterns emerge. You think, oh, okay, this problem is practically begging for a divide and conquer approach.
So it's like less about memorizing algorithms and more about internalizing these problem-solving frameworks.
You got it. It's like learning a new language. You need to understand the grammar, the nuances, the way the pieces fit together. And just like learning a language, the key is practice and immersion.
So put down Duolingo, pick up those coding challenges.
I like it. And remember, that coding interview, it's not just about getting that right answer. It's about showing your thought process. It's about showing that you can Analyze a problem, break it down, explore different solutions. That's what really impresses those interviewers.
It's like being a code detective. You're using your skills to solve the mystery of the tricky interview question.
I love that analogy. So to all you listeners out there prepping for those coding interviews, remember you've got this. You've got an amazing set of tools at your disposal. Practice, experiment, don't be afraid to get creative, and most importantly, have fun with it.
And that's a wrap on another deep dive. We hope you feel equipped and empowered to go out there and rock those coding interviews. Until next time.